Okay, so I don't know where we were yesterday. Maybe it doesn't matter since so many people were gone. Okay, Luke, how do we solve that?
Multiply by 4?
No multiply by 4. Since 4 is,
Multiply by 9.
yeah. If it said like 4k equals 12, it would be divided by 4, right? Yeah. Multiply by 9 to get rid of the divide by 9. So those go away, and we get 4k equals 18. Then what? Divide by 4. Does 4 go into 18? Well, not perfectly, right?
4.2.
No, not quite. Yeah. 18 divided by 4 is, yeah, 4 with the remainder of 2. So it'd be 4 2/4 or 4 1/2. They might have put, I think the book probably, instead of writing 18 over 4, they divide by 2 and put 9 over 2. But these are the same thing.
So will 9 over 2 get you get it right?
These are both right. These are the same thing. Or even 4.5, I won't count that wrong. Okay, I want you to put that away and get your paper back out.
Oh, it's all the way over there.
All right. Oh yeah, I remember what I was gonna say. 4k over 9 is the same thing as 4/9 k. Because 4/9 k is like 4/9 times k over 1, which is like 4k over 9. So what I'm saying this for is, instead of dividing by 4 and multiplying by 9, you could just divide by 4/9 all at once. So you could just divide by 4/9 as well. But this way works too. So we got it. 29. Davin, what should we do first on 29? We're still going, Brian.
Add like so 89 plus 6d is 95d.
Yep. Yep, put the like terms together, now what?
Do the opposite because it's past the equal sign.
Okay?
So that'd be minus 5d, which would be 90d.
Yeah. If you have variables on both sides, like d and d, then you want to get rid of them on one side. So we're subtracting 5d. If you do that to one side, though, you have to do the same thing to the other side to keep it equal. So we got 90d. Negative, yeah, don't forget that negative. Now it's a normal okay, go ahead, Devin.
And then minus 17. So that would be 36, negative 36.
It's a messy one, isn't it? Okay. Some of you get, when the numbers get weird, you start dividing by the wrong number, like 90 divided by 36, especially if this was like a 30. A lot of you would do 90 divided by 30. That's not right. So this is one of the reasons I want you guys to show your work and show it on both sides and everything. Make sure you get it right. To get rid of this 90, we're dividing by 90. So it's negative 36 over 90. Now that doesn't divide, but does it reduce?
Yes.
Yeah, I think so. If we divide both of those by 6,
2 or 5?
actually I think we could do more, but that would be negative 6 over 15. What could we divide both of these by? 3. Your calculators can also reduce fractions. So that'd be negative 2/5.
Will this still be correct?
Yeah, I would prefer fractions unless it's a decimal problem. But, so the problem is when I'm reading this, I'll say like -2/5, like the answer. And then you won't be sure, and then I might not think to say the decimal. It's easier if they're all the same, but yeah, I won't count it wrong on purpose. Anyway. Oh gosh, it's getting big. 4v minus 2v plus 9. Might take me a minute just to write it down. Oh, that's not that bad. It's this next one that's bad. I'm kind of a little bit worried that we forgot how to do 32 and 33.
That's a big problem.
No, we'll talk about it next problem. All right, Atticus, any guesses what we should do first on this one? Well, normally if you see this, like number next to parentheses, you should do that first, because that's like a multiply thing. We can't do anything in the parentheses, can't do v plus 9. So do you know how to do this part? So you do -2 times v, which is, we can't really do anything with that, so it's -2v, and you do -2 times 9. It's called the distributive property because you're passing it out. -2 times 9 is -18. I'll bring this stuff down. Now what do you think we should do? -18 plus 10, and what about these two guys? 4v minus 2v. Those can go together. So 4v minus 2v is 2v, and -18 plus 10 is -8. Now we've got a normal looking problem. By the way, there are more fractions than integers. There's more fractions than not fractions on these answers. I don't know if you guys have done the evens yet or not, but. Okay, now what, Atticus? Trying to get v by itself, how do I get rid of that? Huh? Yep. Always do the opposite, because what gets rid of a -8? A +8. But if we do it to one side, we have to do it to the other. And we still got 2v over here, that would be -6. And how do we get rid of that 2? Right, because that means 2 times v, so to get rid of the times 2, we divide by 2. So we got v is -3. X plus 7 over 4. I think this 5x plus 4 over 20. Equals 5 minus 6 over 5. Alright, this was Friday's assignment. The fractions. And you guys recall, to handle these, we tried to get rid of the fractions. Case, do you remember how we did it?
Common denominator?
Kind of. That's, okay. We're not actually trying to add these fractions together. We want to get rid of the denominators. So we ask, what do the denominators all go into? What do 4, 5, and 20 all go into? 20. So what we did is we multiplied every term this, and this, all three terms, by 20. Now, when you multiply by 20, you're like multiplying by 20 over 1. So really the 20 is just going to go on top. So we're multiplying every term by 20. Okay, but before I multiplied by 20, what did we do? Yeah, the reason we're multiplying by 20 is because 20 reduces with all these divisors. Times 20 divided by 4 makes 5. 20 divided by 20 is 1, so you can put a 1 there or not. 1 times that doesn't really change it. 20 divided by 5, 4. So what happened is all our denominators canceled out, which is what we wanted.
And you just use distributive property.
Distributive property. So we have 5 times that, so. Okay, this part was kind of tricky because you have to subtract not just the 5x, you have to subtract the whole thing. Or you can think of this as -1 times both of these also. So that would be -5x plus 4. Okay, is everybody showing their work, by the way?
Yes.
Okay, and then over here we got 20 minus 4x. Some of these problems take room. If you're not used to making room, you need to change your habits. I don't want you scrunching them all together on one line. You're gonna have to use more paper. It's kind of how it goes the higher level math you get. All right, Case, now what should we do?
You combine 20x plus 4 plus 5x.
Well,
Or
that
minus 5x, sorry.
yeah.
And that would give you 15x. And 35 plus 4 would give you plus 39.
Okay, why didn't you subtract the 4x with these two?
Because it's on the other side of the problem.
Yeah, it's on their own side. It's not together with those. Okay, now what?
Now would you add,
No, go ahead, no, keep going.
now would you add 4?
Okay, yeah. So we got x's on both sides. We want to get rid of them on one side. Now that he's done simplifying. Plus 4x to get rid of the minus 4x over here. And he's got it down to a basic problem.
Then you subtract 39. Then it would be x equals -1.
Yep. All right, so let's look at 32 and 34. I'm not going to do all these, but what should the first step on 32 be? Yeah, what's the common denominator? 6. So you're going to multiply every term by 6, including the 1, even though the 1 doesn't have a denominator. So you do times 6, times 6, times 6. Now, okay, on 34, you could leave the decimals. Actually, it might be less confusing just to leave the decimals. But what's another option? What did we do to get rid of the decimals on Friday? If you multiplied every term by 10, what I mean by term is 0.8n times 10 would become 8n. And then that middle term is 0.3 times 12 minus n. That's all like multiplied together, so that's like one giant term. If you multiplied that by 10, it would just become 3 times 12 minus n. And then the right side times 10 would become 48. So you could do that. You could multiply every term by 10 and just get rid of those decimals.
Would you multiply the 12 by 10 too?
No, because the 10, when you multiply it to the 0.3, is going to be multiplied to the other stuff eventually. So you don't want to multiply by 10 twice. So no, if you just change the 0.8 to 8n and the 0.3 to 3 and the 4.8 to 48, that's fine. Or you can leave the decimals. You should get the same answer either way. That one is a decimal answer. Okay, then I threw in some couple word problems because I know you guys want to do that. Did I? Okay. Yeah, sorry guys, I'm going to add on I want to make sure to do the consecutive integers. So I'm going to add on 46. We still got time. We're almost done. I might open this one up to the class. Let's look at it. 41. A paper boy delivers 13 papers to an apartment complex. These deliveries compose 1/7 of his route. How many papers does he deliver? Kind of a tricky one. Any ideas how we could write that? So let's break it down to really basic sentence. What's it saying? 13 papers is 1/7 of his route. I said route and route. Okay, that's basically what it's saying. 13 papers is 1/7 of his route. So 13 papers is 1/7 of times his route. Okay. So R stands for how many papers he would deliver on his route. Okay, that's how you'd set it up. So how would you solve it then?
Divide by 1.
Right. Divide by 1/7. Dividing by 1/7 is the same thing as multiplying by 7. So 13 is only 1/7 of his route. So it's basically you're multiplying by. You can plug in like divide by 1/7, or you can just plug in times 7. Same thing. Is 42 difficult? Nah, I doubt it. Okay, 42. I'm not gonna do this one, but I'm gonna help you simplify. A candy bar costs 95 cents, which is 19 times the price of a piece of hard candy. What's the price of the hard candy? Okay, a lot of you guys would be able to solve that without an equation, but I want you guys to go ahead and write an equation for practice and then solve it. And by the way, that's what the directions say to do also. Write an equation, solve it. So let's break it down. It basically says the candy bar, 95 cents is 19 times the hard candy. The 95-cent candy bar is 19 times the hard candy. And you're supposed to figure out what the hard candy is. I guess this is an odd. What did this one come out as? 91. Okay. 43. So 41 and 42 were like one-step equations. There's only one thing. 43 and 44 are more like that worksheet we did. They're two-step equations. Like there's a multiplied and an added part. 43, the music department has budgeted $350 for purchases of CDs. Do they even sell CDs anymore? They probably do. How many CDs can be purchased if they cost $15 each and there is a $5 shipping fee for the order? Okay, so we have $350 to spend on CDs. You guys know, like when you order something online, you have to pay for the cost of each thing you order, plus you have to pay shipping, right? So the shipping is what you call a flat fee. It doesn't get bigger or smaller unless you get something like Giant, I guess. But that's one fee. You have one flat fee for shipping plus all the other stuff added together. So it's $15 per CD and $5 for shipping. And altogether, we have $350 to spend. Anybody think they know how to write that one, Hank?
350 equals 15x plus 5.
Yeah. I'm going to call it 15C for CDs, plus $5 for shipping. Because you're going to have to pay $15 times however many CDs you buy, plus you're going to have to pay $5. And you're going to pay, in total, $350. So how many CDs can we buy? I think it's 23, isn't it?
Yes.
Okay, 44 is pretty similar. Let's look at that one. A local natural gas company charges small businesses a $22 monthly connection fee. So they have to pay $22 every month. It's kind of how like a telephone bill works. And $1.20 per therm. Therm, you don't need to know what it means. It's just no, it's a measure. It's just some kind of measurement unit. Okay, you have to pay $1.20 per every this much gas that you use, basically. That's how they measure gas. How many therms were used by a company during a month in which the gas bill was $78.40? So in the month, every month you have to pay $22 no matter what, plus you have to pay $1.20 per unit of gas you use, not gasoline. And altogether they had to pay $78.40. Anybody want to try that one? Yeah, James.
Would you do 1.2t plus 22 equals 78.40?
Yeah. Now, $1.20 times T, that is the same thing as 1.2 times T, that's what he said. Plus, I forgot the number already, 22 equals 70, what was it? 78.40. Okay. And I will probably put a couple word problems on the test, just to let you know. It'll probably be something like this. I'm not going to solve that one since that's even. Okay, 45. Okay, it says one number is 4 times another. How would we, Brooke, how would we write that? One number is 4 times another. You say 1A? N. Okay, 1N. Okay, it's just a different number, so we'll just have to make up a different variable. Okay. Yeah, that'll work. Now, can I solve this? No, I need more information. By the way, the 1 on the N, 1N is the same thing as N, so you don't have to put it. But one number is 4 times another number. Okay, there's not enough information to solve yet. The next sentence says, the sum of the two numbers is 155. You guys remember what sum meant?
Addition.
Addition. So what would the sum of those two numbers be?
N plus 8.
N plus x, yeah. These are the two numbers they're referring to, n and x, which we don't know what they are yet. The sum of those two numbers is 155. Okay, we did a couple of these about a week ago, probably. You guys, anybody remember the trick? I don't think I'll put one of these on this test. However, like in chapter 7, we will have these again. Yeah.
Since n is equal to 4x, you replace the n in the second equation with 4x.
Right. So if n is equal to 4x, this n can be changed into a 4x. That helps because it gives us a one variable equation. Right, 4x plus x, 5x is 155. So we divide by 5. Alright, is that it? Yeah, you gotta watch out, because there's actually two numbers on, some answers have two, or some word problems have 2 or 3 answers. So x is 31, how can I find out what the n is, the other number? Okay, you could plug it in down here and subtract. You could do 4 times x equals n. The first equation, you just plug it back up here into one of these equations, and that'll do it. So 4 times 31 is 124. And you could check it in the other equation. Do they both add up to 155? Okay, 46. I'll have you guys set this one up too. Or you'll help me set it up. Find 3 consecutive integers whose sum is 234. This is kind of basic. Alright, does anybody remember consecutive integers? No, we did a couple of them on Friday or Monday. Somebody hadn't helped yet? Or out of people who've, I don't know, who we need to pick on. It's always Avery. Avery, you might want to change your seat. All the 8th graders are together today. Sophia needs picked on, I think. Sophia, how do we write it?
X plus 2 plus x plus 4.
Okay, that is close. He's 234. There's something a little bit wrong. Okay, this would be consecutive even numbers, or odd numbers, because evens and odds go up by 2. I don't think they said even or odd though. They just said consecutive integers. So, like 5, 6, 7, 11, 12, 13. So, yeah, we should just gone up by 1 on this one. That's it. I do want 3 answers on this. Once you find x, that's the first of the numbers. Like if x was like 10, then your answers would be 10, 11, 12. That's not the answer. Those do not add up to 234, so that's not it. But you can just add your x's together. X plus x plus x is 3x plus 3. Let's try and wrap that up. If you guys need to, you can turn this one in on Friday.
Right.
Yeah.